Assalamualaikum warahmatullahi wabarakatuh. My name is Siti NurSabrina binti Muhammad Sabri. So today I will explain about the experiment 5, gas chromatography. What is gas chromatography? Gas chromatography is the process of separating compounds in a mixture by injecting a gaseous or liquid sample into a mobile phase, typically called the carrier gas, and passing the gas through the stationary phase. The mobile phase is usually an inert gas or an unreactive gas, such as helium, argon, nitrogen, or hydrogen. The stationary phase of microscopic layer of viscous liquid on a surface of solid particle and or in solid support inside a piece of glass or metal tubing called a column. The surface of the solid particle may also act as the stationary phase in some columns. The glass or metal column through which gas passes is located in an oven where the temperature of the gas can be controlled and the effluent coming off the column is monitored by a computerized detector. Principles of gas chromatography. A sample is being injected at the inlet or injector and vaporized into the chromatographic column. The sample is transported through the column by the flow of inert gases mobile phase. As the sample passes through the column, they are separated and detected electronically by the detector.
The material we use are acetonitrile, ethanol, red wine, rice wine, whiskey, and thermoquestress GC2000. First, 10 grams of ethanol and acetonitril were dispensed into 1000 ml volumetric bottle to prepare the standard solution and ethanol standard solution. Then, 1% ethanol was mixed with 1% acetonitril in various ratios. The RRF value is calculated by generating a linear regression line to be used in equation. Ethanol content is determined by using direct injected GZ method. 5 and 10 ml of 1% ethanol was added into 0.5 ml of red wine and whiskey respectively in 20 ml vial. Then 5 ml of 1% ethanol standard solution was added. After gentle mixing, 0.1 microliter of sample solution was injected into GC for the determination of the ethanol content. Ethanol content was calculated according to this equation. Each concentration of ethanol standard solution was measured in triplicate, and this experiment is repeated by using rice wine.
Data and result. Analysis of gas chromatography. Figure 1a shows gas chromatogram ethanol and acetylnitrile in alternating compound. Figure 1b shows gas chromatogram ethanol in non-distilled spirit, which is red wine. And the last one is figure 1c, show the gas chromatogram of ethanol in distilled spirit, which is whiskey, by spiritless injection method. Next, Table 1 shows result of determination of ethanol content in alcoholic beverage using direct injected gas chromatography method.
Assalamualaikum warahmatullahi wabarakatuh. My name is NurHanani Fatiha binti Azhar, and in this slide, I will present about discussion for experiment 5. In this experiment, the terms of application is the simple, rapid, and direct injected capillary megapore column TC method developed in this study has demonstrated more benefits and values. Currently, different beverage samples necessitate distinct sample preparation procedures with pre-treatment consisting of distillation or dilution. Furthermore, current capillary GC methods necessitate lengthy sample pre-treatment procedures such as solid phase extraction headspace balancing, solvent extraction, and distillation. The study method we devised is simple and quick, requiring no sample pretreatment procedures. After mixing the beverage samples with an adequate amount of the internal standard solution, the samples are ready to be injected into a GC for ethanol content determination. Typically, the ethanol content of commercial alcoholic beverage is labeled in volume percent. It is sometimes more convenient to be labeled with volume percent. After the beverage samples was mixed with an appropriate amount of internal standard and injected into a GC for ethanol content determination, the relative response factor was calculated by generating a linear regression line to be used in the equation. This equation was used to calculate the ethanol content, which is this. The ethanol content of 3 commercial alcoholic beverages, which is 2 distilled spirits and 1 non-distilled spirit, was determined using the research method. The ethanol content of 2 distilled spirit was 326.3 mg per ml, 2.4% in whiskey, and 158.2 mg/ml, 3.8% in rice wine, as shown in Table 4. In red wine, the ethanol content was 107.4 mg/ml, which is 2.7%. The ethanol content of this alcoholic beverage was consistent with their labels and no fraud was discovered.
Assalamualaikum, my name is Syafiqah and I'm going to continue on the last part, which is conclusion. So in this experiment, direct injected gas chromatography is used to determine the ethanol content in alcoholic samples. So this method also can be applied to alcoholic beverage with different alcoholic contents and with this advantage of simple sample pretreatment procedure, rapidity and accuracy. So from this experiment also, we know that the whiskey contains the highest ethanol contents than the other alcoholic samples. Okay, so this is our reference and that's all from us. Thank you.
Next, we will proceed with the experiment case. Determination of caffeine in beverage by HPLC, high performance liquid chromatography. First, introduction. What is HPLC? HPLC is an analytical technique used for the separation of components of an organic mixture compound. The process begins when a small amount of liquid sample is injected into the column that has a stream of liquid flowing through, which is known as the mobile phase. The polarity of the component and the type of the HPLC being performed determine which the phase of component is more attracted to. If the component is more attracted to the mobile phase, it will flow out of the column and have a shorter retention time. If the component is more attracted to the stationary phase, the component will be retained and therefore have a longer retention time. In reverse phase HPLC, the stationary phase is nonpolar, which is hydrophobic in nature, while the mobile phase is polar liquid such as acetonitrile. It works on the principle of the hydrophobic interaction. Hence, the more nonpolar the material is, the longer it will be retained. In short, the most polar component emit first. It will increase the mobile phase polarity and will increase the elution time. The reverse phase chromatography principle affirms that separation in reverse phase chromatography relies upon the reversible adsorption or desorption of soluble molecule with the changing of level of hydrophobicity to the hydrophobic stationary phase. Caffeine. Caffeine is a common chemical that we interact with on a daily basis and have access to many forms. The systematic name for the caffeine is 1,3,5-trimethylxanthine. Its chemical formula is 6C8H9 and 4O2. The chemical structure of the caffeine is shown here. Caffeine is added to the soft drink as a flavoring agent. It is a part of the overall profile of soft drink, which consumers enjoy for the refreshment, taste, and hydration. In this experiment, reverse-phase HPLC method was validated for determination of the content level caffeine in soft drinks, energy drinks, tea, and coffee.
My name is Siti NurSabrina binti Muhammad Sabri, so I will continue the methodology part. The material that we are using in experiment 6 are Pepsi Cola, Coca-Cola, Red Bull, tea, coffee, and also the isocratic waters HPLC. Standard solution preparation. Caffeine stock standard solution of 1000 ppm was prepared by dissolving 0.1000 gram of caffeine standard in 80 ml distilled water and sonicated it for 10 minutes. The standard solution was transferred to 100 ml volumetric flask and the volume was complete to mark by distilled water. The stock solution was stored in dark place at temperature positive 4 degrees Celsius. These standard solutions were prepared by suitable dilution for stock solution and prepared freshly. When the sample bottles were opened, the three were degassed by sonication, homogenized and filtered. Then each sample was filtered through 0.5 micrometer shrink filter with 5 ml shrink. The filtered drink sample of 2 ml were 5 times diluted in distilled water. 20 microliter of each diluted sample was injected into HPLC column. The relative peak areas were determined for 3 replicates of each dilute sample. The concentrations of dilute sample and the concentration of caffeine in soft drink sample were calculated from calibration curve. The sample of Pepsi Cola was spiked with 20 ppm caffeine standard solution for recovery determination and the experiment was repeated by using Coca-Cola and Red Bull. Tea and coffee sample preparation. 2 grams of tea samples was weighed and put into 250 ml beaker. Then 100 ml of boiling distilled water was added and let to stand for 5 minutes with stirring. The solution was cooled and filtered into conical flask. 5 ml of filtrate were pipetted into clean 50 ml volumetric flask and made to the mark with distilled water. The sample were filtered through 0.5 micrometer shrink filter and run in the HPLC system according to experimental conditions. The tea sample was piped with 20 ppm caffeine standard for recovery determination and this experiment was repeated by using a coffee.
From these results, we can see that the highest caffeine concentration in beverage samples was obtained in tea sample. This was followed by energy drinks, then coffee sample. The least was obtained in both carbonated drinks. The mean values of caffeine daily intakes were 41.76 mg for carbonated drinks, 81 mg for energy drink, 176 mg for tea, and 101 mg for coffee. These are the chromatogram graph obtained for caffeine standard 20 ppm, Coca-Cola sample, energy drink sample, and black tea sample.
Assalamualaikum, my name is Syafiqah and I'm going to continue on discussion part. So in this experiment, simple high performance liquid chromatography is used for determination of the content levels in 5 different beverage samples. So HPLC is a technique that involves the injection of a small volume of liquid sample into a tube packed with tiny particles called stationary phase, where the individual components of the sample move down the packed tube with a liquid and pass through a column by high pressure. So the separation of the sample ingredients are caused due to different constituents of a sample that are elute at the different times. In this experiment, the result shows that the highest caffeine concentration is Lipton and the lowest caffeine concentration is Coca-Cola. So in the black tea, there's a longer infusion time and a higher stepping temperature, and because the black tea is fully oxidized, so it allows more caffeine to be extracted from the leaf, while the carbonated soft drink, the caffeine is only added to enhance its flavor. So in this experiment, the daily intake of caffeine is estimated, and according to the International Food Information Council, the consumption level of the caffeine for adults in US is approximately 200 milligrams, and it may indicate that contribution from the beverage in the intake of the caffeine is 92%, 51%, 32%, and 90% for tea, coffee, energy drinks, and soft drinks, respectively.
Assalamualaikum warahmatullahi wabarakatuh. My name is NurHanani Fatiha binti Azhar, and I'll present conclusion for experiment 6 in this slide. In this experiment, the validated HPLC method for quantifying caffeine in beverages was discovered to be simple, precise, sensitive, and accurate, allowing for good results. Despite the small number of drink samples examined, the data presented in this study provided a preliminary outline of the content levels in tea, coffee, soft and energy beverages commonly consumed in Sudan. Lastly, this analytical measurement was carried out primarily to assess the compliance of caffeine content levels and daily intake doses with the allowable levels. Lastly, in this slide is the reference that we use in this experiment. And that's all from us. Thank you.